What's up, guys? Today we're gonna explain about DNA damage and repair.
So, DNA, the over-traumatic queen, always breaking, always crying, always needing repair.
Honestly, if DNA had a mood, it would be fragile but surviving. Before that, hi, I'm Mimi. So I won't waste your time no more. Let's go to our first mechanism of DNA damage and its repair mechanism. Let's go.
Bulky base changes and NER.
Nucleotide Excision Repair repairs DNA damage produced by physical agents such as damaging UV radiation. UV light produces pyrimidine dimers, which are often formed between two neighboring thymines on one of the DNA strands. These two thymines form bonds with one another, altering the DNA strand in that area of the molecule. So, nucleotide excision repair relies on endonucleases, which produce two incisions in the DNA strand, one on the 3 side of the damage and one on the 5 side, leaving a fragment of 12 to 24 nucleotides with free ends that are susceptible to exonucleases. Exonucleases then remove the nucleotides. Finally, DNA polymerase inserts new nucleotides, and DNA ligase seals the bonds once again.
Let me simplify this for you. Bulky base changes are like DNA got sunburned, and the bases stick together like your clingy axis. And then NER shows up with scissors. Cut it out and patch it clean. Now, it's basically the plastic surgeon of the genome. Snip, snip, glow up.
Hi, I am Ain. So next, we move to the second DNA modification. DNA normally has 2 strands that can separate during important process like replication and transcription. But when certain chemicals appear, they mess things up. Crosslinking occurs where chemical bond will be formed between the 2 DNA strands, which is called interstrand, or within the same strand, which is called intrastrand, locking them together. These crosslinks will prevent the DNA from being read or copied correctly. This can stop cells from functioning properly or even cause the cell to die. Don't worry, we have our repair team, which are Fanconi anomia protein, nucleases, translation synthesis polymerase, and homologous recombination protein. These special proteins will detect the problem, cuts the one strand to remove the crosslink, copies the missing DNA using the backup strand, and seals everything back together. But, did you know that scientists use this on purpose to fight cancer cells? Clever, right? Some chemotherapy drugs, like cisplatin, use this method to kill cancer cells by damaging their DNA so they can't multiply.
Hi, I'm AIMAN. Today, I want to share something pretty cool, a behind the scenes to look at how your cells fix tiny mistakes in your DNA. It's called Base Excision Repair, or BER. Now, our DNA isn't perfect. Every day, little errors can pop up, like a G being replaced where there should have been an A. It's not a disaster, but if those small mistakes piles up, they can lead to bigger problems like mutation. Here's how it works. First, a special enzyme called a DNA glycosylase finds and removes the faulty base. This leaves a little gap called an abacic site. Then another enzyme, which is AP endonuclease, cuts the DNA strand at the spot. Next, DNA polymerase adds the correct base, and DNA ligase seals everything up like nothing ever happened. To help you really see how this process happens, I've added a simple animation that's helpful for visualizing what BER actually looks in action.
If just one base is damaged, it can usually be fixed by a process called base excision repair. One enzyme snips out the damaged base, and other enzymes come in to trim around the site and replace the nucleotides.
That's where BER comes in. It's like your cell's personal editor. It quietly scans the DNA, spots the damage or incorrect base, and fixes it before anything goes wrong.
Hi, my name is ATIQAH NAJLA and I will explain to you the last section of this video. So, let's go! Oh my god, do you hear the alarm? Apparently, the main chaos has finally arrived. These double-strand breaks can happen when your DNA are exposed to genotoxicants such as X-rays and gamma rays. This can lead to breaks in both strands of the double helix in your DNA. Double-strand breaks can be very dangerous because it can lead to cell death. Your DNA will undergo DNA repair mechanism which are called HR and also NHEJ. Let's watch a simple video to understand more about this.
The most common pathways for repairing double-strand breaks are called homologous recombination and non-homologous end joining. Homologous recombination uses an undamaged section of similar DNA as a template. Enzymes interlace the damaged and undamaged strands, get them to exchange sequences of nucleotides, and finally fill in the missing gaps to end up with two complete double-stranded segments. Non-homologous end joining, on the other hand, doesn't rely on a template. Instead, a series of proteins trims off a few nucleotides and then fuses the broken ends back together. This process isn't as accurate. It can cause genes to get mixed up or moved around, but it's useful when sister DNA isn't available.
If you want to compare between HR and NHEJ, HR strands are perfect. Meanwhile, NHEJ can sometimes lead to mutation. NHEJ is like your friend who fixes your phone by using a hammer, which is not so helpful. In conclusion, yeah, your DNA is under constant attack and your cells are working 24/7 to repair your DNA. Next time, if you are tired, just remember that you are still doing better than your genome. That's all from us. Thank you for watching and listening. Stay safe, stay stable, like your DNA.